f of x equals 6 over x for part b, and a equals -1. We're going to need f at a, which is f at -1, to give us -6. By the definition, f prime at a equals the limit f of x minus f at a divided by x minus a as x approaches a. Our case, the a is -1. Replace it into the limit definition. F of x, which is 6 over x, minus f of a, which is -6, divided by x minus -1 as x approaches -1. Simplify the numerator. You get 6 over x plus 6 divided by x plus 1 is the same as multiplied by the reciprocal, which is 1 over x plus 1. The numerator 6 over x and plus added by 6, we see the common factor 6. Factor it out to be 6 multiplied by 1 over x plus 1, and then multiplied by the quantity 1 over x plus 1 as x approaches -1. Find the common denominator for the first factor, which is x. The numerator is 1 plus x, and multiplied by 1 over x plus 1. As you see, x plus 1 and 1 plus x will be cancelled. Therefore, we are going to find the limit of 6 over -1 as x approaches -1. This is a constant, so the limit as x approaches -1 will become -6. Next, we find the equation of the line. For the equation of the line, we use a formula y minus y1 equals m times x minus x1. Y minus the y1 is -6. The m, which is the slope, that what we just found, or m of the tangent, is -6. Multiplied by x minus x1, which is -1. Or y plus 6 equals -6 times x plus 1. Y equals -6x minus 6 subtracted by 6 both sides to become y equals -6x minus 12 as the equation of the tangent line, where the slope is -6. Next example, f of x is square root of 9x plus 1 for a equals 7. The f at a, or f at 7, is square root of 9 times 7 plus 1, or 63 plus 1, which is 64. Square root of 64 is 8. The f prime at a. This time, let's use another form of the definition, which is the limit f of a plus h minus f at a divided by h as h approaches 0. So f prime at 7 equals the limit h approaches 0, f at the a, which is 7, plus h minus f at 7 divided by h. We already found f at 7 equals 8. Let's set on the side the f of 7 plus h is square root of 9 times 7 plus h plus 1, or the square root of 63 plus 9h plus 1, which is 64 plus 9 times h. replace it into the limit definition equals the limit h approaches 0. F of 7 plus h now is replaced with 64 plus 9 times h in the square root minus f at 7, which is 8, divided by h. This becomes the limit involving the radical form. So we use the technique to find the limit by multiplying by the conjugate both top and bottom. So multiply by the square root of 64 plus 9h plus 8 divided by square root of 64 plus 9h plus 8. The numerator is 64 plus 9h, which is from squaring the square root. Squaring and square root take care of each other. 8 and 8 is 64. And the denominator is the product of h and square root of 64 plus 9h plus 8. Simplify the numerator. We obtain 9h. Next, h and h reduce. It becomes the limit of 9 on the top divided by square root of 64 plus 9 times h plus 8 as h approaches 0. And the limit value becomes 9 over square root of 64 plus 8, which is 9 over 8 plus 8, or 9 over 16, as the slope of the tangent line. So next, we're going to find the equation of the tangent line. So the equation y minus y1 equals m times x minus x1, where the m of the tangent line equals 9 over 16, and the order pair x1, y1 that we found from the beginning of the problem. X is 7, the y is 8. So the equation of the tangent line would be y minus 8 equals 9 over 16 multiplied by x minus 7. On the right hand side, 9 over 16 times x minus 9 times 7, which is 63. 63 over 16. On the left hand side, y minus 8. So y equals 9 over 16x minus 63 over 16 plus 8. And these two numbers has a common denominator 16, negative 63 plus 128 divided by 16, which gives us 65 over 16. Therefore, the equation of the tangent line is 9 over 16x plus 65 divided by 16.